Big Bang was like one of those Escher boundaries, but it's nice and smooth, and you can imagine that you could continue this universe to outside that region.
The James Webb Space Telescope might have just uncovered something mind-blowing, a whole other universe beyond our own. This isn't just a wild theory, it's coming from a Nobel Prize-winning scientist, Roger Penrose. He believes the JWST's images reveal clues that point to our universe being only one in an endless cycle of worlds. Could this change everything we know about space and time? Tune in as we explore the shocking details that will uncover hidden universes that were there all along, under our noses. The universe might have existed before ours. Imagine our universe expanding, just like a balloon getting bigger. Instead of expanding forever and fading into nothingness, one physicist thinks it will eventually reset itself. This isn't just a random idea, he's even found something in the cosmic microwave background, CMB, that might support his theory. The CMB, by the way, is like the baby picture of the universe, the first light that formed after the Big Bang, about 14 billion years ago. He calls these strange spots in the CMB Hawking points, and he thinks they could be marks left behind by black holes from a universe that existed before ours. It's like cosmic fingerprints from a party we weren't invited to. Before we delve into this, it's clear that these Hawking points could reveal a reality far stranger than anything we've imagined. And this won't be the only thing that will shock you. The whole idea of a never-ending universe is kind of wild, right? Especially when you think back 100 years or so. Back then, people mostly thought the universe was steady, just stars being born, galaxies hanging around, and everything staying pretty much the same overall. Then came discoveries that flipped our understanding upside down. Scientists realized that all the distant galaxies are actually moving away from each other, which means the universe is expanding. It wasn't just static, it was alive in a sense, always stretching out further. But what he is proposing goes even further. The universe isn't just expanding, it's doing so in a cycle, like a cosmic reboot. The path to this idea starts with the Big Bang, a point when everything, space, time, energy, all started about 14 billion years ago. Back then, the idea of an expanding universe was pretty radical, shaking up the old belief that everything had always been more or less the same. But that wasn't the end of the questions. One big question still lingered. If everything started with the Big Bang, what happened before that? Was there even a before when time itself didn't really exist yet? These questions weren't just complicated, they twisted people's minds into knots. Some, like the famous Stephen Hawking, said it's pointless to even ask what happened before, Born. It's like asking what's north of the North Pole. But this physicist, he's not buying it. He thinks something did exist before, another universe. He calls this idea conformal cyclic cosmology. Basically, he believes that at the very end of our universe, after all the stars have burned out and all matter has turned to energy, the cosmos will become one giant empty stretch of radiation. Nothing has mass, nothing ages, and because of that, the idea of time kind of just fades away. And then, boom, a new universe is born, another Big Bang, kicking off a fresh cycle. It's a pretty bold idea, but he thinks that he can even see the traces of this process. That's where those Hawking points come in. They might be clues to what was happening before our Big Bang, the remnants of black holes that existed before our universe. To understand where he is coming from, it helps to know a bit about black holes and why they matter so much. In the 60s, he and Stephen Hawking worked together on black hole theory, showing that these strange objects aren't just theoretical constructs, they're real, and they're deeply connected to the laws of the universe. Black holes form when stars collapse under their own gravity, compressing all their mass into an incredibly small space, so dense that not even light can escape. They're like cosmic trash compactors, swallowing everything that gets too close. The idea of a black hole even existing was once seen as far-fetched, like some sort of weird math quirk. But he helped show that they're real and predicted by Einstein's theory of general relativity. And in 2020, he was finally awarded the Nobel Prize for this work. Fast forward to now, and he is taking this idea of black holes and flipping it into a theory about the entire universe. At the end of everything, when black holes have swallowed most of what's left in the cosmos and then evaporate into nothing through a process called Hawking radiation, He believes they leave behind Hawking points, faint echoes from a universe that has since gone. These points are imprinted in the CMB, like scars or echoes of a past we can only faintly see. He says these faint points are evidence that a previous universe existed, one that came before ours. Essentially, they're like a cosmic breadcrumb trail leading us to the idea of a cyclical universe. The idea that the universe might start over is surprising, but what happens right before everything begins again could completely change how we think about it all. The start of something new in space. To see how the universe might go from being vast and empty to suddenly exploding into a new Big Bang, you have to change the way you think about space and time. Imagine everything stretched out infinitely. Eventually, distances and times become so long, they don't mean anything anymore. Time and space sort of lose their meaning. At this point, he says, the universe can reset, collapsing back into a tiny dot from which a new Big Bang bursts forth. It's almost like hitting a giant cosmic reset button. A lot of scientists still aren't convinced, though. For one, the evidence he has for Hawking points is far from universally accepted. Sure, there are weird spots in the CMB that he and his colleagues have pointed out, but interpreting those spots as remnants of previous universes is controversial. The CMB itself is a snapshot of what the universe looked like roughly 380,000 years after the Big Bang. It's considered one of the best pieces of evidence we have for the Big Bang theory because it's the oldest light in the universe, a leftover glow from the time when the cosmos was just forming. But interpreting patterns in that glow isn't straightforward. There are lots of things that can cause strange spots or anomalies. Some scientists argue that the Hawking points he claims to see could be the result of random fluctuations or noise in the data. Others think they might be evidence of something else entirely, not necessarily past universes. Still, he is confident that these points are telling us something deeper about the nature of existence. To him, they're not just a curiosity, they're a smoking gun for his cyclical universe theory. It's like finding a footprint and saying, look, this proves someone else was here before us. Not everyone is buying it, but he thinks the evidence is clear. Another interesting part of his theory is how it relates to entropy, the idea that everything in the universe tends towards disorder over time. In the traditional view of the universe, entropy keeps increasing until you end up with heat death, a point where everything is evenly spread out and there's no usable energy left. Just a boring, cold universe with no activity. But he suggests that at the point of maximum entropy, when everything is just radiation, the universe loses its concept of scale. Since everything is spread out evenly, there's nothing left to compare distances or time. It's this weird state that lets the universe forget its past and start over again. His ideas might sound outlandish, but they're actually grounded in solid physics. The mathematics behind his theory check out, and while the observational evidence is still up for debate, the concept itself is at least possible. It's not the only alternative to the standard Big Bang model, though. There are other theories like the Big Bounce, which suggests the universe goes through cycles of expansion and contraction like a cosmic accordion. Others think the universe could be part of a larger multiverse, with countless other universes coexisting alongside ours, each with its own laws of physics and histories. The cyclical universe is just one of many attempts to answer the big questions. Where did we come from, and where are we going? Even if this theory is ultimately proven wrong, it's still important because it challenges our understanding and forces scientists to think in new ways. The beauty of science is that it's always evolving. Theories that seem wild today might be tomorrow's accepted truths, just like how the idea of black holes was once considered crazy. And remember, even the Big Bang theory itself was met with skepticism when it was first proposed. It took decades for enough evidence to accumulate before it was widely accepted. In a way, his vision of a cyclical universe is comforting. It suggests that the end is never really the end. It's just the start of a new chapter. The universe isn't just going to fade away into nothingness. Instead, it will rise again, reborn in a new form. Everything that ends will begin again in a cycle without true death. For some, that's a hopeful thought. The idea that even when everything seems like it's over, it's really just the beginning of something new. But this comforting cycle is not without its critics. Many researchers argue that his theory leaves too much up to interpretation. What looks like evidence of past universes to him might in fact just be noise or anomalies that have nothing to do with cosmic cycles. The scientific community is, by nature, cautious. Before embracing a revolutionary idea like conformal cyclic cosmology, they demand clear and indisputable evidence. And right now, despite his confidence, the evidence for Hawking points is far from indisputable. As we look closer at these ideas, it's clear not everyone agrees, and the search for proof is only just starting. The debate over space's big clues. Critics have pointed out that the analysis of CMB data is notoriously difficult. The CMB is a faint glow that has traveled for almost 14 billion years to reach us. Along the way, it has been influenced by everything it has encountered: gravitational pulls from galaxies, interstellar dust, and even the expansion of the universe itself. All these factors introduce noise into the data, making it incredibly challenging to extract meaningful information. The spots that he points to as Hawking points could be artifacts of the methods used to clean up the CMB data, rather than genuine remnants of a past universe. Moreover, the theoretical framework of conformal cyclic cosmology relies on certain assumptions about the nature of space and time that are not universally accepted. For example, it assumes that the universe can transition from an infinitely expanded state to a new Big Bang without any significant changes in its fundamental laws. This assumption is at odds with the more conventional view that extreme conditions, such as those at the beginning or end of a universe, would require new physics, something beyond our current understanding of general relativity in quantum mechanics. Even within the field of cosmology, there are numerous competing ideas about how the universe might evolve. The Big Rip, for instance, is a scenario in which the expansion of the universe eventually becomes so rapid that it tears everything apart: galaxies, stars, planets, and even atoms. In this view, there is no graceful transition to a new universe, just an increasingly violent expansion until nothing remains. Then there's the heat death scenario, where the universe simply cools down as stars burn out, black holes evaporate, and all energy is evenly distributed. In this version, the universe ends in a whimper, not a bang. Despite these challenges, he remains undeterred. He believes that the mathematical beauty of his theory is a strong indicator of its truth. In physics, there's often a sense that the most elegant solution is the correct one. His vision of a universe that cycles endlessly from one Big Bang to another is certainly elegant. It ties together concepts from general relativity, quantum mechanics, and thermodynamics in a way that no other theory quite manages. For him, the universe's story is one of eternal rebirth, an unending cycle that transcends the boundaries of time and space as we understand them. Penrose also draws on philosophical arguments to support his theory. The idea of an eternal universe has deep roots in human thought, appearing in various forms in different cultures and philosophies throughout history. From the Hindu concept of the universe as an endless cycle of creation and destruction, to the ancient Greek philosopher Heraclitus' idea that everything flows and the cosmos is in constant flux, the notion that the universe is eternal and cyclical resonates with our deepest intuitions about existence. Penrose's work can be seen as a modern scientific expression of these age-old ideas, bringing them into the realm of empirical science. Of course, philosophical resonance is not enough to convince the scientific community. What's needed is concrete, testable evidence. And this is where Penrose faces his biggest challenge. The data from the CMB is tantalizing, but not conclusive. To convince his peers, Penrose would need to show that the Hawking points he has identified could not be explained by any other means. This is a tall order, given the complexity of the data and the many different processes that could produce similar-looking features. One possibility for strengthening Penrose's case is future observations. The next generation of telescopes and space missions will provide even more detailed maps of the CMB, allowing for a closer examination of the features Penrose has highlighted. If similar patterns are found with greater precision, it would lend more weight to his theory. Conversely, if these patterns turn out to be statistical flukes or the result of data processing techniques, then Penrose's idea will face a significant setback. Another avenue for testing Penrose's theory could come from gravitational wave astronomy. If our universe is indeed part of a cyclical process, there might be subtle signatures in the gravitational waves that ripple through space-time. These waves, which were first directly detected in 2015, offer a new way of probing the universe, one that is not limited by the challenges of studying electromagnetic radiation like the CMB. Detecting gravitational wave patterns that align with the predictions of conformal cyclic cosmology could provide the kind of smoking gun evidence that Penrose needs. Yet even if the evidence for Penrose's theory remains elusive, the impact of his ideas is undeniable. He has pushed the boundaries of what we consider possible, forcing us to think about the universe in new ways. The notion that the Big Bang was not the beginning, but just a transition, redefines our place in the cosmos. It suggests that our universe is not unique, but just one in an infinite sequence, each with its own birth, life, and death. This perspective is both humbling and awe-inspiring, reminding us that the cosmos is far grander and more strange than we can ever fully comprehend. Whether or not Penrose is correct may be less important than the questions his theory raises. Science is as much about the path as it is about the destination. By proposing a bold new way of looking at the universe, Penrose has invited us all to join in the quest for understanding. The universe is a vast and strange place, and the more we learn, the more questions we uncover. Perhaps one day we will know for sure whether our cosmos is part of an eternal cycle, or if it is destined to fade into oblivion. Until then, Penrose's ideas serve as a powerful reminder of the boundless possibilities that lie beyond the edge of our current knowledge. Even with what we know, the universe has so much we don't understand, and new ideas bring even more questions about what might be out there. What we still don't know about space. The universe is one giant question that no one truly understands, not even the smartest scientists out there. Sure, we know a lot more now than we used to, but when you look up at the stars, there are still so many things that make you scratch your head. The more we find out, the more questions seem to pop up. It's like the universe just loves keeping questions, and we're all playing catch-up trying to figure it out. Let's dive into some of the biggest questions that have everyone confused. One of the first questions that gets people thinking is, where did all this come from? Most scientists believe in the Big Bang theory. They say the universe started out as a tiny, dense point that exploded, expanding super fast and growing into what we see today. But then you have to wonder, what was there before the Big Bang? How did that tiny, dense thing even exist in the first place? These questions are a real headache because we just don't have enough clues to figure out what went down before that massive explosion. We can only guess, and none of the guesses seem all that certain. Another thing that's confusing is what the universe is actually made of. Everything we can see, all the stars, planets, and galaxies, only makes up about 5% of what's out there. The rest of it? Well, it's called dark matter and dark energy. Dark matter isn't like the kind of matter we know about. You can't see it, and it doesn't give off light. We only know it's there because of the way it messes with gravity. And dark energy? That's even weirder. It's thought to be the reason why the universe keeps expanding faster and faster. But nobody really knows what it is. Imagine trying to study something that you can't see, touch, or even really prove exists. It's tough, to say the least. Then there's the problem of matter and antimatter. When the Big Bang happened, it should have made equal amounts of matter and antimatter. But when matter and antimatter meet, they cancel each other out. So if there was equal stuff of both, everything should have been destroyed. Yet here we are in a universe full of matter and no antimatter in sight. It's one of those big cosmic questions. Why is there so much more matter? Scientists have some ideas, but nothing that fully explains how we got here. Black holes are another head-scratcher. These are supermassive objects that have so much gravity that not even light can escape them. The really big ones, called supermassive black holes, sit in the middle of most galaxies, including ours. How did they get so huge? Did they start small and just eat up everything around them? And then there's the information paradox. If you throw something into a black hole, it's like it's gone forever. But that goes against some of the rules of physics. We're still not sure what happens to the information about whatever falls into a black hole. It's like there's a chapter missing from the physics book, and we're waiting for someone to fill it in. There's also talk about something called the multiverse. This is the idea that our universe might not be the only one. There could be an infinite number of other universes out there, each with different rules, different histories, and maybe even different versions of us. It's a wild idea, but it's also almost impossible to prove. If other universes exist, how would we ever see them or interact with them? It's a bit like trying to prove there are other fish bowls when you're stuck inside one. So in the end, we have all these amazing questions about the universe: where it came from, what it's made of, and what its future might be. Every answer we get just seems to lead to more questions, and that's part of what makes the universe so fascinating. We're a long way from having all the answers, but the path of figuring it out is what keeps us going. The universe doesn't give up its answers easily, but that just makes the chase all the more exciting. Could the James Webb Space Telescope really be showing us another universe? Or is this just a bold claim without proof? Share your thoughts and remember to like and subscribe for more.